Okay, so we are starting the class. Last time we did common ion effect, and this common ion effect is very important for unit 8 also, and for buffer solutions, even for this Ksp is very important. So let's have a review of this common ion effect, and because we did completely the common ion effect. If in this equilibrium, this is a solution, this is a weak base. What's the meaning of a weak base? The one which is not 100% dissociated. Not 100% dissociated. Right? Okay. Means there is some dissociation, like some Mg2 plus. Okay, Aslisha, you want to leave the class? Not a problem. You can watch the recording, okay? Right now I'm in a class. I will be busy for classes for nearly. Aslisha is asking some questions in the private chat. So I will be busy throughout the day. Okay, so I can make it available only in your midnight. You can see it in your morning. Okay. Okay, children. So what is a weak base which is not 100% dissociated? It's only partially dissociated, you can see. Now in this equilibrium, if I add NaOH, NaOH is a strong base, which is Na plus and OH minus. It's a strong base, right? Now when I add OH minus, extra OH minus in this equilibrium, this is strong. Why I'm repeating this thing again and again? Because I want you to understand that a strong base is 100% dissociated, 100%. There is no equilibrium. So you can see equilibrium only in weak bases or weak acids or weak electrolytes, the one which are not 100% dissociated. But if it is a strong electrolyte, a strong base, a strong acid, then there is no equilibrium, it's single arrow. So that is the reason I'm repeating it again and again. So when you add OH minus in this equilibrium, in which direction this equilibrium will shift? It will shift to the left, Le Chatelier principle. If it is shifting to the left, what is happening to the solubility of this solid? Is the solubility increasing or decreasing? You are shifting to the left. This is solid. You are shifting in the direction of solid. It's decreasing. The solubility decreases. So when the equilibrium shifts to the left, solubility decreases. Means you are getting more solid. You are going in the direction of solid. And one more thing decreases. It becomes more weaker acid. More weaker. It will become more weaker. More weaker base. It's a base. So more weaker base. So here you can see that when we add a common ion, the common ion makes your base more weaker. Similarly with acid. If I give you a weak acid, if you remember the solubility rules, a weak acid is completely soluble. All acids are soluble, rule number 1. So this is completely soluble, but it's a weak acid. It means it's only partially dissociated, not fully dissociated in water, like this. It's a weak acid. That's why I'm representing it by an equilibrium. Now I take a strong electrolyte. A strong electrolyte is KCl. KCN is a strong electrolyte which is completely soluble. This is the part of Unit 8 also, Afan, but I'm just doing the common ion effect, which is there in Unit 8 also. You're right. K plus aqueous plus Cn minus aqueous, right? Now, what's the effect of this common ion on the above equilibrium? Effect of this common ion on the above equilibrium. The above equilibrium will shift to the left, and this acid will become more stronger or weaker. It is going in the direction of undissociated acid. You are getting more undissociated acid, means is becoming Aditi, Ariba, and Azuni. You three are wrong. Lisa is right. It's going in the undissociated direction. Undissociated means less dissociation. Dissociation is decreasing. Less dissociation. Equilibrium is shifting to the left. Less dissociation. Less dissociation means your acid is becoming more weaker acid. More weaker acid. Please understand this. This will come again in buffers. Unit 8. Common ions. It will come there. So we are good with this? Common ion effect. Now I'm starting the new topic, that is solubility product. Solubility equilibria. So I'm going to teach you a few things here. Solubility, meaning of the solubility product means meaning of the Ksp, meaning of the solubility equilibria. So understand this. It's a very interesting topic, very, very interesting and simple. It's completely based on the equilibriums. Okay, that concept we have done, the Chatelier principle and all these things. Ready? Understand every term, everything. And you will see that you can memorize it here in the class only. First of all, children, we are talking about equilibrium constant K. We started learning about Kc, then we learned about Kp, then now we are going to learn about Ksp. It's only equilibrium. All of them are equilibriums. Expression writing, how to write down K expression, the magnitude of K, the mathematical operations on K, the Lee-Chatelier principle, whatever we did, all are applicable. Then in unit 8, you are going to do Ka, acid dissociation. A means acid, Kb, B means base, base dissociation, Kw, water dissociation, Kf, this we are not going to do. Formation of a complex, Kd, dissociation of the complex. So the type of the equilibria will decide the name of the equilibrium constant also. Okay, so these are very important, all these. So in this unit 7, we are going to do Kc, we have done, Kp we have done. We are doing Ksp now, the last. And in unit 8, we are going to do all these. Okay. So Ksp, let's try to understand Ksp. Ready? Okay. Someone of you is making a solution of sugar. You have taken 1 liter water. And you have started dissolving NaCl into it. NaCl, common salt. You're adding. NaCl is very soluble, very, very soluble. You know that, always soluble. But when you're dissolving this NaCl in 1 liter of water, you will reach a point, though it is very soluble, but still you will reach a point when you cannot dissolve more salt in water. Like, for example, sugar. You are making a solution of sugar in 1 liter of water. You check with your mother, you ask her, she will tell you that she can dissolve, though it is very soluble again, because it can make hydrogen bonds with water. It's very, very soluble, like dissolves like unit 3, solubility. We did solubility there. It's also very soluble. But you'll reach a point when no more sugar is going into water. It starts settling down at the bottom. Same with NaCl. What happens when no more solid is dissolving in water? We call that solution as saturated solution. Saturated solution. What is a saturated solution, children? Where there is an equilibrium between the solid and the ions, like in NaCl ionic compound. So ionic compound is going to dissociate like this in ions. So there is an equilibrium here. Like sugar, solid. Now in the saturated solution is an equilibrium with sugar is a covalent molecule. It's a non-electrolyte. It is C12H22O11. It's not going to split into ions. It will stay like this only. C12H22O11. But it is now in aqueous form. So what's the meaning of a saturated solution? That there is an equilibrium between the not soluble and soluble part. Means it is the state of the solution when you cannot dissolve more amount of the solid into water. But is dissolution stopped? No. Dissolution is still happening. And what is dissolution? Dissolution is going in this direction. Solid to these ions. This is dissolution, children. This one. Dissolution. Solid to aqueous. So at the time of equilibrium, dissolution is still going on. Equilibrium is a dynamic state, you remember? But at the same time, the precipitation is also happening. This one. Going in the reverse direction. So the red arrow, the top, this red arrow indicates dissolution. Dissolution of the solid in solution, in water. And this arrow, this one, is precipitation. So what is happening at the time of equilibrium? The dissolution has not stopped and the precipitation has not stopped, but the rate of dissolution is equal to the rate of precipitation. So a saturated solution means, this can be a question. What's the meaning of a saturated solution? It means no more solute can be dissolved in water. This is for young children to understand the meaning of saturated solution, the one who are in 9th standard or in, I have students who are in 5th standard. They are doing YBTC with me. So it's better they use this word saturated solution is something when you cannot dissolve more. It's good for them. But for AP students, the meaning of saturated solution means equilibrium, means the rate of dissolution, whatever amount is undergoing dissolution, exactly same amount is undergoing precipitation, is rate of precipitation. So as AP student, you should understand the meaning of saturated solution in this manner. Are we clear? Dissolution and precipitation. Anyone has any problem till now? The meaning of saturated solution? In a solution, we express the concentrations of these ions in terms of, in a saturated solution, we are going to say it as S. It's a saturated solution where S is the molar solubility. Molar solubility. And what is molar solubility? It's concentration of these ions, this sugar. It is moles per liter. How many moles are there in 1 liter? Are you clear about this word, children? S. Are you clear? Okay, good. Very good. So this is the introduction part that we are talking about solubility. Solubility means making a solution. Ionic solids, covalent molecules, electrolytes, non-electrolytes, all these solubility terms we did in unit 3 based on attractive forces. And we did the rule like dissolves like. But here we are doing mathematics. We are understanding the equilibrium. These are, all of them are ionic solids, all of them. The table you can see, all of them. Can you look at their Ksp values? Is these Ksp values are greater than 1 or less than 1? Check. They all are less than 1. Less than 1 means what is more, the solid or the aqueous? Less than 1 means products are less. The equilibrium is favored by reactant, not by product. That is the meaning, right, Anil? Okay, so this Ksp is very low value, so they are not dissociated. They are very less dissociated. So we can call them as weak electrolytes. They are ionic solids which are weak electrolytes. Weak electrolytes means very, look at the Ksp value, very low, very less dissociated into ions. Dissociated into ions. Please review unit 3. Review unit 3 to understand this why they are less dissociated. Because what is the meaning of weak electrolytes? Weak electrolytes, strong electrolytes. For that, you have to review unit 3. Okay, so we are dealing with weak electrolytes here in this Ksp. Ready? Pick up one ionic salt. Let's pick up this one. Now, children, do you have your polyatomic ions list with you and the solubility rules? Do you have? I gave you the solubility rules and polyatomic ions. Do you have that with you, children? Anyone? If you can share it again here in the chat. I'm also trying to share it. So take out your polyatomic ion list and The solubility rules. And check if you have the solubility rules also. Okay. Download them, open it. I've shared both of them. We are going to use it. Okay, let's work with mercury 2 sulfide. Right now the formula is given. HGS, and take out your periodic table also. This is the solid. Now I'm placing this solid into water and making a saturated solution. So it means saturated solution means it's going to set up an equilibrium, right? So what is the ion present here in Hg? For that, you should work with sulfur first. Look at the periodic table. What can be the charge on sulfide? What can be the charge on sulfide? All of you, please look at the periodic table. Check the position of sulfur. As a sulfide is an anion, is going to gain electrons. How many electrons sulfur can gain to complete the octet? Yes? You have the periodic table, children? So what is the charge on sulfur? Yeah, it has 2 minus charge. So we are going to put this as AQ. So this I worked out from the periodic table because this is a pure element, and we can work out the charges on the anions based on the position in the periodic table. Then what is the charge on this mercury? If this is 2 minus, this is 1:1. So this is the unit again. I think I did this in unit 1 or 2. Somewhere we did this nomenclature. Review that. Can you see that? How this HGS is going to split as Hg2 plus and S2 minus? It's a transition metal, mercury. It shows different oxidation number. Here it is showing 2 plus, so you are using Roman numeral 2. All these things we did. Here this mercury is 1C. So we have to represent for the transition matter like manganese, Mn is also transition matter. Lead is also Lead also shows different oxidation numbers. So we have to show for the lead also, though it's not transition metal, but it's quite heavy and below lead. Then tin also. For that also we have to show. Yes, Anil, we did that. We did all these things earlier. Just a review. Okay, so this is the equilibrium. This is a saturated solution. Saturated solution. What is the K expression, which I'm going to call it as Ksp? You will come to know why. Solubility product, solid into solution. What's the Ksp expression for this equilibrium, children? It is the concentration of the product Hg2 plus times concentration of the other product S2 minus. Do I have to take this solid in the denominator? This solid will not come, no. So don't write anything. So don't you think that this is just the product of the ions in the solution? Product of the ions for all of them. Ksp is just the Sp means it is the solubility product. Solubility. And solubility product is only in terms of concentration of ions in water, right? This is in water. All these solutions are made in water. Any question about the Ksp? This is the Ksp expression for this. Ready for next concept based on this? Afan, you are listening, but you're not answering. Afan, are you there? Don't make me call your name for answers. You know, children, I'm planning to share these chat messages in the group chat. I just want to be sure that all of you are answering. Naisha, not Nisha, Lisa. Naisha, you are there, I know, but I'm sure that you must be slightly troubled because few classes you missed. So no, don't worry. Just pay attention, ask your questions in case you have any question. Okay? So Naisha is the youngest student of this class and she is very sensible, working very hard. Okay, children, this is your KSP, right? Expression. If I say this is a saturated solution and its molar solubility, the solubility of this compound is S, then it is a solid. So I can make the initial change equilibrium table. This is solid. Put a dash here because solid is not the part. Initially, when you added this solid, how much Hg2 plus is there? Initially, how much? 0. How much S2 minus? 0. Now let's say S moles, S is the molar solubility. It's a new term. I'm not using X here. You remember earlier we were using X for the change. Here we are using S. Molar solubility is S. So it means S moles of this HGS per liter have gone into the solution. This is solid. This is solid. So we are not interested. But how much Hg2 plus has come? Isn't it S? S moles 1 is to 1. 1 is to 1 is to 1. How much this? S. Remember earlier we were taking the change as X. X. Now in place of X, we are taking S. That's it. Okay? Meaning is the same. Now at equilibrium, this is 0 plus S, S. This is 0 plus S, S. What is Ksp expression in terms of molar solubility? What is it? S times S, S squared, isn't it? So this is how I'm going to write down Ksp expression for a salt, which is in the ratio of 1 is to 1, AB type, AB type. And if you know Ksp, which is given here in the table, we picked up this example. If you know Ksp, you can work out S. If you know S, you can work out Ksp. Like what is S here? Ksp is given. 4.0 times 10 raised to power minus 54 is S squared. So what's the molar solubility of the salt? Is the square root of this number. Children, this is a new concept, though it is based on equilibrium. But I hope you are understanding what I'm talking. It is 2.0 times 10 raised to power. Take the square, half of this. Is it clear? Okay, for all AB type, Anil is asking what is AB. For all AB type of salts, Ksp expression will be this only. Like for example, if I give you Ag and AgBr, solid, this is AB type salt, AB 1:1. It will dissociate to give you Ag plus aqueous, Br minus aqueous is a weak electrolyte. I'm making a saturated solution, right? If I say the molar solubility of AgBr is S, then how much Ag plus we are getting? S. How much Br minus? S. What is Ksp for this particular reaction? Concentration of Ag plus times concentration of Br minus, that is S times S squared. That's why I said all AB type salt where the cation anion are 1:1 ratio, Ksp expression will be S squared for all AB types, right? Lisa, you're getting this? Half of the exponent means? Yeah, this is S squared. So what is S? Square root. Square root means if you take 4.0 raised to power half, that you know is 2, but exponents, it would be minus 54 divided by 2. So that's why I calculated without using calculator. She's talking about this one, Azuni. Children, I'm going to save the chat of meeting chat and I'm going to share on group broadcast where parents can also see. So please, all of you, try to interact because I will question why this particular student is not interacting. So don't sleep in the class. Try to interact. I know that you are not sleeping, you are doing work, but the problem is that it's very important. I want to see whether you are understanding in the right manner or not. When you try to answer here, then only I get to know, oh, he's taking this in the other way around. So I want to correct you. I want your understanding to be 100% correct. So answer here. Ready for next? Let's pick up this salt. This one. Now let's write down the equilibrium of the saturated solution. Saturated solution. Saturated solution means BaF2 solid. What type of salt is this? Is it AB? No, it is AB2 type, right? See, AB2. 1:2. This type is this. So I'm going to call it AB2 type. Is undergoing dissociation. There is an equilibrium. Can you tell me what is the charge on Ba? Look at the periodic table. Give me the charge on Ba. Give me the charge on F. Ba is in the second group. Yes, 2 plus aqueous. And how many Fs will formed? 2F, right? With 1 minus. Very good. Fluorine is 1 minus. Is fluoride now. Fluoride. Barium ion and fluoride ions. Because they are 2, so I'm getting 2 here. Say again. Yes, Azuni, in total. But I'm not asking in total. I'm asking what is the charge on F, not on 2F, right? But yes, that's how you can work. If this is 2 plus, there are 2 fluorines, so it means each fluorine is 1 minus. Okay, now let's say the molar solubility of this compound is S. S is the molar solubility. S is number of moles per liter. So make the rice table. So initially, how much BaF2 is solid? Okay, before you go for this, write down the Ksp expression. Ksp. Solid is not the part. So only the products. Concentration of Ba2 plus raised to power is coefficient 1 times concentration of F minus raised to power 2. That is the Ksp expression. The solid is not there. So in the rice table, we need not to worry about solid, right? Initially, when I added this solid in the water, how much is Ba2 plus? 0, 0. Now, S moles are undergoing dissolution per liter. Molar solubility is this. So how much Ba2 plus? See the ratio. 1 is to 1 is to 2. So this is S and this one is 2S. So equilibrium S 2S. Ksp in terms of molar solubility, Ba2 plus is S, F minus is 2S squared. S and 2S, right? Squared. Here, this is 2S. Plug in this 2S here and then take the square. Ksp expression is 4S cubed. For any AB2 type salt or A2B type salt. If you have a salt of this ratio 1 is to 2 or 2 is to 1, Ksp expression in terms of molar solubility will become this. Those who are not getting it can ask their questions. Afan, you're understanding? Afan, answers please. No, you can work out. You will see if it is AB, if it is AB, you need not to memorize it. AB solid, then the ratio in which they are getting A plus, B minus, or A2 plus, B2 minus, or A3 plus, B3 minus, whatever, right? If this is S, 1 is to 1. So Ksp, which is only in terms of concentration of these two, is S squared. This is for AB, all AB types. And if it is, let's say, A to B, this one, A to B, so I can say that I will get 2A, let's take 1 plus, aqueous, plus B. Now it should be 2 minus, only then it is neutral, aqueous. Now write down the Ksp expression. If S is the molar solubility, this is 2S, this is S. So what is Ksp? It is the concentration of A plus raised to power 2, concentration of B2 minus raised to power 1. So A plus is 2S, 2S raised to power 2 times S. How much is this? 4S cubed, right? So A to B type, where the ratio is 2 is to 1, 1 is to 2, you have to use this 4S cubed, right? You can practice and you can understand also. So I'm not asking you to memorize, I'm asking you to practice. If you practice, definitely it will go in the memory. Yes, then the questions will be that they have given you Ksp, solve for S, or they have given you S, solve for Ksp. Let's make a salt of A3 plus with B1 minus. What's the formula? I want all of you to type here. A3 plus and B1 minus. Yes, AB3. Okay, now you're going to give me Ksp expression in terms of molar solubility. Let's say the molar solubility of this compound is S. Now it's going to dissociate as A plus aqueous because, oh, A3 plus, charge is 3 plus, right? And 3B minus aqueous. If the molar solubility is S, so we are not making the complete rise table. Generally, we are writing in these questions like how much A3 plus? S. Just put a dash. We are writing final equilibrium. And how much B minus? 3S. What's the Ksp expression here? Which is the concentration of A3 plus times concentration of B minus raised to power 3. So plug in these values, this one here. What it will be? Anil, you're ignoring this 3? Are you taking only SS, Anil? It will be 227S raised to power 4. Yeah, you're getting it, Anil? You have to plug in S and 3S. Children, this error, many students, nearly 90% students, they do this error. But someone are working and trying to correct it. But those who are not answering, not doing, not writing, they will repeat this error in the exam. So please do it. We are clear? So whenever you have AB salt, it is S squared, SS. Whenever you have AB2 or A2B, then one is S, other is 2S. When you plug in, it becomes 4S cubed for these two. But whenever you have AB3 or A3B, then it will become 27S raised to power 4. Afan, what is S here? What is S? Any one of you? What is S? I'm using S as, what is it? Yes, very good, Anil. It is molar solubility. Afan, molar solubility. What are the units of S? Units of S. Moles per liter. Afan, I'm not getting answer from you. Moles per liter. Yes, very good, Afan. Okay. See, children, if some student is in trouble, like I generally come to know that this particular student, my student, is struggling. So I start calling the name. It's not that it's bad. Sometimes we are not catching up properly. That's why. Can happen. So this is your Ksp expression for AB3 or A3B. So now I'm giving you another example. You're going to give me Ksp expression for that example. There is a salt with A3 plus and B2 minus. Can you make the formula? Formula of the salt. A2 B3, I have taken this solid. I'm going to make a saturated solution, equilibrium. What I will get here? 2A, this 2 will come in front. 3 plus, these are the ions I'm getting in the solution. Plus, what else? 3B, 2 minus, right? If the molar solubility of the salt, molar solubility means S, molar solubility is S of this solid, how much this will I will get? This one. Check the ratio 1:2. So how much this I will get? How much this? Anil, you are in a hurry. How much this I will get? Isn't it 2s? And how much this I will get? 3s. Come on, Anil, write on the Ksp expression first. What is Ksp expression for this particular reaction? A 3 plus raised to power 2. You're not doing that, Anil, in your calculation. B 2 minus raised to power 3. A3 plus is 2s. 2s raised to power 2. B2 minus is 3s. 3s raised to power 3. Again, no. 2s raised to power 2 is 4s squared. 3s raised to power 3 is 27s raised to power 3. It is 108 s raised to power 5. Lisa, is 2s whole squared. 2s. Just place A3 plus concentration as 2s. 2s whole squared. 3s. B2 minus as 3s. And take the cube of that 3s. Means 3 also. 3 times 3 times 3. 27. 2 times 2. 4. 4 times 27. 108. Yes, Anil. Because follow the steps. You will not do any error. First, you write down the Ksp expression. First, you write down the equation, children. Then plug in these S. Assume the molar solubility is S. Then this will be 2s, 3s. Write down Ksp expression. Plug in this 2s and 3s and get the Ksp expression in terms of molar solubility. So follow these steps. First step, salt is given. Write the equilibrium for saturated solution. This is first step. Assume molar solubility as S. Assume. Then complete this equilibrium in terms of S. Write down how much A3 plus B2 minus like this. Write Ksp expression in terms of ions like this. Plug in this 2s and 3s there. Go slow initially. Anil, you can be very fast later on, but initially when we are learning something, don't try to miss even a single step when you are learning. When you have mastered it, yes, you can miss the steps. Like here, if somebody asks me, what is this? I'll say 4s cubed. I will not do anything because I know it. Practice. I didn't memorize, I practice. Okay. So when you are learning new things, go step by step to minimize errors. We're good. So now we have done different types of salt. AB. What is the Ksp expression of this type of salt? This is type. What is the Ksp expression in terms of molar solubility? All of you, please try to answer. A2B. What is the Ksp expression in terms of molar solubility? AB2. What is the Ksp expression in terms of molar solubility? AB2. It's the same. 2:1. 1:2. Same. If I give you AB3, what's the Ksp in terms of molar solubility? Yes. If I give you A3B, what's in terms of molar solubility? Same. Afan, you are trying to answer? No. Okay, if I give you A2, B3, what is in terms of molar solubility? Yes, S raised to power 5. And if it is A3, B2, same. So basically, if you see, you're going to deal with only these type of salts. How many types? One, two, three, four. Only four types based on chances, because maximum I can have plus 3 or minus 3. That's it. With that, you have these are the only options of the salts. Is it okay? Ready for questions now? Yes, you're right. But like here, concentration of A2 plus raised to power 3 times concentration of B3 minus raised to power 2. That's the Ksp expression. But A you are getting 3. So it will be 3s raised to power 3. This 3 is also in the parenthesis. And this B3 minus, how many B3 minus you are getting? 2. See this 2 number? So it will be 2s raised to power 2. And that's how, when you solve it, this 3 cubed and 2 squared, you'll get 108. Is it okay? Afan? Yes, you are answering. Good. Ready? Now we'll try to identify these salts from the formulas. What type of salt is this? AB, A2B, AB2, what type? It's a polyatomic ion, children. All these are binary. One is metal, other one is a polyatomic ion or a non-metal. Yeah, it is AB. Lisa, very good. This is AB. What are the ions here? Ba2 plus and CO3 2 minus. That's why I gave you the polyatomic ion list. This is also 2 plus. This is 1 is to 1. 2 plus 2 minus. S squared. This one. What type of salt is this? Yes. So it is 108 S raised to power 5. Right? Okay. If I give you AlF3, oh, it's here. What type of salt is this? This one. AB3. What is Ksp? Yeah, 27 S raised to power 4. What type of salt is this? So Ksp in terms of S is 4s cubed. So this thing is very much clear to us. Okay, now we are with the questions. So rest of the things we'll try to understand with the help of questions. The rest of the topic is just questions. Read the question. Here is a pictorial representation. And you can see there are 3 beakers. Beaker A, B, C. These beakers are showing you strong electrolytes or weak electrolytes. This question was there in unit 4 also. Beakers are showing you strong or weak. the salt which you have added, is it completely soluble or it's not completely soluble? Do you have any solid at the bottom? Do you have any solid? Yes, this is solid. See, tightly packed at the bottom, tightly packed solid. So it's a weak electrolyte. Weak electrolyte. Can I compare their solubility? Can you tell me which one is the most soluble and which one is the least soluble here? Which salt is most soluble? The salt of A, B, or C? The one which is giving you more ions in the water. B, yes. And which one is the least? C. So the solubility order of these salts are like this. You can see from the picture. B is giving you the maximum amount of the ions in the water, but A is giving you less and C is even giving you more lesser, right? Okay, this is one way that they have given you the picture, and from the picture you can see more ions in the solution and you can easily compare their solubility. This is another question. In this question, okay, this question we have already done 2 times. They are asking you to give it example of the salt. So what can be salt here? Which type? You know the type, right? What type? AB. I've given you the polyatomic ion list. I have given you, you have the periodic table, polyatomic ion list. Can you give me one example of AB type? You have the solubility rules. So please pick up weak electrolytes. Weak electrolyte is a strong, Azuni, very strong. Weak electrolytes means which are not completely soluble, the one which are with less solubility. Use the solubility rules. Yes. You check the one which are very less soluble. Sulfides, S2 minus are very less soluble. So you can pick up something like CUS. Okay, yeah, barium carbonate. Yes, Lisa, very good. Barium carbonate. BAS is soluble, Anil. Check the rule for sulfides. Solubility rules I gave you. I think it's rule number, which rule number is that? Rule number 4. 5 is for hydroxides, I think. Yeah, AgOH, very good, Aditi. AgOH. Check rule number 2. AgCl, AgBr. All these are examples. AgI. All these are less soluble, weak electrolytes, AB type. Their Ksp is H squared. Can you give me example of this? So first you identify what type of salt? What type of salt? Hmm. If you take AB3, then it means A has 3 plus and B is 1 minus, right? Like this. What are AB, A3 plus? Very popular 3 plus ions are Al3 plus, Fe3 plus, Bi3 plus. These are the popular cations with 3 plus. So you can make with them. But don't make chloride, bromide, iodide. Check the rule number 2. Chlorides, bromides, iodides are strong electrolytes. So you can pick up something like this, AlOH thrice. Rule number 5 for hydroxide. You can pick up FeOH thrice, like this, right? These kind of compounds. BiOH thrice. Or you can take A3B. A3B will be rare because here you have A plus with B3 minus. They are very rare example. B3 minus generally is N3 minus, P3 minus. These are 3 minus. So I think this is best example. So this is just practice of the Ksp expression in terms of molar solubility. Can you do this? We have plenty of this. You can give me example of A to B type or AB to type. Plenty of them. Plenty and plenty. Barium, which is 2 plus, right? And you can take something which is 1 minus. Don't take nitrates. Don't take hydroxides because barium hydroxide is a strong base. So you have to use your, I think barium 2 plus. I should not take this example because most of its compounds are soluble. So let's take copper 2 plus. That is there. So you can take CuOH twice. Let's take S2 minus. So you can take Cu2S. That's a compound. Copper can show you 2 plus and 1 plus. So I'm telling you all these things, but my aim is to make you understand how to make formulas, how to look at the charges, and how to identify this Ksp expression. That is the aim. Otherwise, I don't think they will ask you this question. Okay, so question will not be there. Ag2s, yes. But still, I'm interested. I'm doing it so that you become more familiar with writing of the formulas, the charges. I want you to look into the polyatomic ion list. Okay, so this can be a practice of writing the formulas also. Okay, ready for next? Okay, look at this A question. They're asking you to compare the molar solubility, means S. S will tell you which one is more soluble and which one is less soluble. So look at this first salt. What is the Ksp expression, children? For the first salt, Ksp. Yeah, it is Ab2 type. Very good. So it is the, in terms of molar solubility, yes, 4s cubed. S Ksp is given. Can you work out S? What is S? Don't do error in mathematics. And give me the value of S, the molar solubility in terms of units. You have to give the units also. Scientific notation up to 2 significant figures. Afan, you are doing it? Pick up your calculators and plug in the value. Take care, this complete has to be in parentheses. Or you can plug in this equation as such. You can plug in this equation as such in your calculator. Or you can do some changes and then plug in this one, only this value. For this above, you need a graphing calculator. For below, you can do it in a normal calculator. And Aditi, Lisa are giving me different answers. Yes, who is going to confirm? Who is right? Okay, I think Lisa is right because Azuni is also giving me the same answer. So Aditi, check your calculations. So 2.2 or 3, 10 raised to power minus 4, 10 raised to power minus 4 moles per liter. Molarity, right? Molar solubility. Can you calculate As for the second one, what type of salt is this? Again Ab2, right? So again the Ksp expression is S squared, 4s cubed, sorry, 4s cubed, which is 2.4 times 10 raised to the minus 5. See this Ksp expression for CaF2 and BaF2 is same. So S is 2.4 times 10 raised to the minus 5 divided by 4, then this is cube here. So it will become 1 over 3 on the other side. I hope you know this mathematics. We have done this in 0 unit also. What's the answer? Get the value of S. So which one is more soluble? 0.018. Let's put it in scientific notation. 1.8 times 10 raised to power minus 2 moles per liter or molarity. Or you can write molarity like this. Which one is more soluble? Compare their solubilities. Compare this value with this value. Which one is more soluble? BAF2 or CAF2? This is BAF2 calculations. This is CAF2 calculations. The second one, BAF2. Because right now I asked you to calculate the solubility also. But you know that you can answer this question without calculating S. How? Because they have the same expression, S squared, and this is also, sorry, 4S cubed, and this is also 4S cubed. They have the same expression. You just compare their Ksp values. The one with high Ksp value, this is high. Because expressions are same, only then you can compare. The one with high Ksp will have high solubility, right? So in the A part, please write down in the A part, you can compare Ksp values because it has the same expression, because the type of salt is same. So Ksp expression in the A part is same, 4s cubed. So if this value is high, S is high. If this value is low, S is low. Very simple. But this is only when they have the same Ksp expression for molar solubility. Is it okay? Okay, now let's see the B part. Ready for B? In this case, for the calcium phosphate, this one, what's the Ksp expression? You know, it is A3B2. This is an ion, polyatomic ion. It is 108 S raised to power 5. And for BAF2, oh sorry, not BAF2, this one, FePO4, this one. What is the Ksp expression? This one, not BAF2, this FePO4. Fe is 3 plus and PO4 is a polyatomic ion, children, this one. They are 1:1. Yeah, AB type, yes. It is AB type. So Yeah, Aditi, no problem. S squared, very good. If I compare their Ksp values, one has this, other has this. From the Ksp values, what do you think if I compare Ksp, which I cannot? But let's say if I'm comparing by error, then according to error calculation, error thinking, which one is more soluble? AB type or A3B2 type? That is more soluble. Now you will see it is wrong. Let's prove it that I cannot compare. Why? Because of this expressions are different. Check here. What is S here? 1.3 times 10 raised to a minus 32. So what is S? Can you calculate S? That is 1.3 times 10 raised to a minus 32 divided by 108. I've taken this number here, raised to power 1 over 5. If you have any mathematical problem with the exponential, watch the video in 0 unit about exponential. Otherwise, use your graphing calculator and plug in this to know S. Okay, Lisa is giving me the answer as 1.6 units. I think your answer is right. Units, moles per liter. Okay, this is S squared, and this S squared is equal to 1.0 times 10 raised to minus 22. So what is S here? I think we don't require a calculator. I have to take the square root of that. That's it. Units, molar. Now, can you compare the molar solubilities of these salts? Which one is more soluble? Now, from comparing the molar solubility, don't you think this is the first one? This value is high. This value is low. It's minus 11, minus 7. Children, I spend so much time on exponentials, mathematical functions, exponential in unit 0. So this one is more soluble. And Azuni is asking a question. Children, can you help her? She's saying this KSP is more. This is what you're thinking, Azuni? Is this more? Minus 32 and minus 22. Which one is more, Azuni? Minus 32 or minus 22? Yes. So this one is less. If I just compare KSP, then I would have reported other way around. I would have said calcium phosphate is less soluble. But no, it is more soluble. See, you check the calculation. Yes, Anil is explaining her. Azuni, can I ask you to review that exponential video from unit 0? Okay, that will clear everything. Okay, good. So this is how we have to compare the solubility. If their Ksp expressions are different, calculate S. If Ksp expressions are same, then just compare Ksp. Like for example, I give you one more question here. Let's say there is a salt. Okay, let's come here on the table. Here, let's compare the solubility. Question is, what is the solubility? Compare the solubility of these two salts. Which one is more soluble? So first you think about the Ksp expression. Is it same or different? It is same, S squared, yes. So don't calculate S, just compare Ksp. Now tell me which one is more soluble. HGS or NIS? NIS is more soluble because this value is high, yes. But if there is a question in which, if I say compare the solubility of these two, then it's a tough question. You have to calculate because this is S squared and this is 4S cubed. Then do not compare their Ksp values. Calculate S and then decide. Is it okay? Okay. This question, solubility means molar solubility, S. This is the salt. What type of salt is this? Calcium has 2 plus, C2O4 has 2 minus. What type of salt? AB. Children, I've given you polyatomic ion list. Go through it. Check. I'm not asking you to memorize. I'm asking you to practice it. Keep looking into it. Can you see this ion there? Can you tell me the name of this ion? Oxalate. Right? Okay. So I'm not asking you to memorize. AP is not asking you to memorize anything, but it's important to visualize the compound. You should know that it is AB type. So what is Ksp expression for AB type? S squared. And that is 4.8 times 10 raised to a minus 5. So what is S? Square root of this. That's what they're asking. What is the solubility? Means they're asking S. So just take the square root of this and plug in the units, moles per liter, or you can say molarity. Ready for next type? B type. Afan, you're not answering again? Whoever is not answering, please start answering. These are simple questions. Okay. What type of salt is this? AB3. So what is the Ksp expression? Is 27 s raised to power 4, which is equal to this. Oh, this time. Oh, I think we did the question wrong. Children, you didn't stop me. This is solubility given and they're asking Ksp. See, the solubility is given, right? Ksp is not given. Solubility is given. Oh. They will calculate the Ksp when the solubility is given. So S is given. This is S. So what is Ksp? Just the square of that number. No units now. Equilibrium constant has no. If you feel like that, I'm doing some error because my focus is more on teaching, making you understand. So sometimes I don't read the question carefully. Yes, that's it. And no units for Ksp. Now B part. The solubility is given. This is moles per liter. This S is given. So 27 times 1.32 times 10 raised to minus 5 raised to power 4. And solve it. And don't put any units. No units. Equilibrium constant has no units by convention. Can I clear this? So this was very simple question. Solubility is given, identify the salt. Let's do one more. Afan, try to answer now. See this question, Afan. In this question, they are asking the solubility. Afan, are you there? Yeah, he's there. Okay, good. Do this A part. What type of salt? Type of salt, children. Anil. No, why? Can you see this 3 here? Is A3B. A3B, right? So what is Ksp? 27 s raised to power 4, which is 1.8 times 10 raised to power minus 18. Ksp is given. No units, you can see no units. But this s will have a unit. So it is 1.8 times 10 raised to power minus 18 divided by 27 raised to power. Here it is raised to power 4. On the other side, it will become 1/4. Exponential mathematics, right? And solve it. Final answer will have the units of moles per liter. This is A part. So we are not solving it, children. You have to practice your calculator now. B part. Can you check this? What type of salt is this? So Ksp equals to S squared. Ksp value given. No units for K is S squared. So what is S? It is the square root of 8.7 times 10 raised to power minus 9. And now it has a units because it's solubility, moles per liter. B part, C part. This is B we have done. Now we are doing C part. In the C, I want you to use your understanding of the ions and their dissociation and answer it. What type of salt is this? Yes, it is AB2. AB2, a fun, because they are saying that when you take Hg2Cl2 and you put this solid into water to make a saturated solution, this is not going to split. It's going to be as such as a dimer, like this. That's what they are saying. But this will give you 2Cl minus. So if this is S, this is 2S. So Ksp is the concentration of this, that is S, times concentration of this raised to power 2, that is 2S raised to power 2. So it is 4S cubed. So it is AB2 type salt. A and then 2B, AB2. Is it okay? Is it clear to all of you? And then you have 4S cubed equal to that Ksp value, this one. And then you can work out your S. From here, the units will be moles per liter. Aditi, if you check my polyatomic ion list, Hg like this is very unstable. It's unstable. It's never like this. You can never see mercury with +1. It will never be in this form. Mercury +1 cannot exist. Cannot. But there is mercury 1 plus oxidation number. So how it is existing as dimer? There are two mercury 1 plus which are combined. So what's the charge per atom here? 1 plus, right? It's a dimer. So that hint will be given to you in the exam. Okay, children. So that's about the molar solubility, Ksp. I have made your life very simple by giving you practice on how to write down Ksp expression in terms of molar solubility. Life is simple. You are just saying, oh, use s square, 4s cubed. Then it's just mathematics. But very soon we have to do questions where you have to write down the equilibrium of the saturated solution. Means now you should practice how to find out the charges on the ions. So these type of questions, which I will be starting in the next class, but please don't leave the class. I have to discuss something. Those who are trying to leave the class, hold on.